is Nonlinear, and today in this video presentation I will be showing you guys how I modeled my Abaqus project on the topic nonlinear collapse analysis of a scissor car jack. So first of all, I have created the parts individually in the SolidWorks, and now I will be firstly showing you guys how to create the base plate. So I have used the front plate. I'll be sketching it over here. First a straight line vertically down up to the axis, and a horizontal line up to the from the axis, and now a straight vertical line. Then after down I will be using 3-point arc, and I will be creating an arc up to here, and then I will be using a straight line from here to here, and I will be now assigning the dimensions of each one of them. That is 12 millimeter, and this is 72 millimeter, and then this is 50 millimeter. This is 32.5 millimeter, and now I will be assigning the radius of this one, that is 50 millimeter. And now after this one I will be creating this line as a construction geometry line, and now I will make a circle in the middle, and now I will assign the dimension of the circle as 12 millimeter, and then I will make this distance as 31 millimeter, and this distance as 19 millimeter. And then I will be now creating a mirror entity of the whole surface, and I will mirror it about the geometry line here. And then now I will extrude this image and up to 12 millimeter, and now this is the part this is the base almost completed. And now after this one I will use the front plane, and I will create a reference geometry plane about this one, and this one's length would be 37.5 millimeter. And now about this first plane I will mirror it and mirror the body. I will mirror the first body on this first plane, and we should not merge the solids together, so untick the merge option here, and then this created. Now I will be sketching about the mirror plane. Use a corner rectangle from here to here, and then extruded boss piece. Now first of all you will make it up to the surface, then surface you'll select this surface, and now other direction too, you'll also make it up to the surface and then you'll select this surface, and this is the first. Now you'll hide this plane one, you can hide it, and now this is the first part that I've created, that is the base plate. Now I will be saving this one. Okay, and here I will be parts, and now I'll be saving first this part as base. Okay. I will be showing you guys how to create the arms. So we'll be creating that one in the top plate, sketch, and then use straight slot, and then here straight slot from here to here, then smart dimension them. Before that one you have to add one circle on the left side and one circle on the right side, and now you use smart dimension and make this distance 200 millimeter. Then this radius you can make it 12.5, and then after that one, then this part make diameter 12, And same goes for the right part, make diameter 12. And then after that one you have to extrude it up to 6.5 millimeter. And now we have created the arms. Now you have to just save this model and save it as arms. Okay, I will be showing you guys how to create the screw rod. So first of all, we have to create the screw rod in the right plane, right? So we'll sketch in the right plane and make a circle and this from this axis, make it 50. Then you have to extrude it, make it 50, extrude up to 50. And now after that one you can do in the mid front plane sketch, and then you have to sketch one circle straight from here, and then make that one dimension as 12, and then from here to here make the distance as 25, and then this one done. Make sure this one and this one they are on the same axis, and after that one you have to extrude it cut, and then draw, you can say mid plane, and just increase it, and then you will be making a hole here, but you don't actually need this hole because we won't be using actual screw and thread and all. And now here you have to sketch on this one, make a circle, and now this will be the screw rod diameter. Screw rod's diameter, it should be 25 millimeter, and then extrude it up to 500 millimeter, and with that one you will be getting this screw rod part. And now you have to save it as screw rod. I'll be showing you guys how to create the top plate. So we'll choose the top plane, sketch, and then straight slot, make a straight line, and then make it upwards. Then again add two circles here, assign dimensions 12 millimeter each, 12 millimeter, and then this length should be 50, and then this radius should be 12.5, and then after this one you extrude it, and then you have to extrude it up to 38 millimeters. And now the base, the top plate has been created. Then you just save it as top plate. Now I will show you guys how to create the mid plates. So we'll be creating that in the top plate. Sketch, use a straight slot, make a straight line and then extend it upwards. Then make two holes, and then you assign the smart dimension 12 millimeter, and this one also 12 millimeter, and this should be 70 millimeter, and this radius should be 19, and then after that one you have to extrude 38 millimeters, and now it's complete. Now after that one you have to use here on this surface you have to sketch a center line from this mid to the bottom mid, and then now you will on this center line you'll create a circle. The circle's dimension should be 26 millimeter for the screw rod to pass through it, and then now you will extrude that cut through all, now down. So this is how we get the mid plate, and you just have to save it as middle plate. After you have created the parts, now you will assemble all of them. So now I will use the assembly module, new assembly module. Now first you will import the base part, and then you will import the remaining parts one by one. This is the top plate, this is the arms, this is the screw rod. Base we have already imported, and this is the mid plate. And now this is the things that you will be assembling. So let's keep this arms, mid plate, top plate aside. First let's make the base plate fixed. So first of all let's float it. Now it's movable right now. So let's fix it. So we will fix it with top plate with the surface, front plate with this surface, and then right plate with this surface. So after you have done this, your base should not be movable at all, as you can see. Now we will be making the arms. So before we just have one arm, so if you want to create multiple arms you have to Control C and drag this. You can just drag it and you'll get the arms. So let's meet the arms with the base plate now. The edge of this one with this one, same with the other one, this one with this one, same with this one with this one. But as you can see it's right now inside, so you have to make it outside. And now this one with this one, and now make it outside. So this is how your base plate should be. Now you have to add mid plates to the arms. So okay, so you have to create two mid plates. So let's just Control C and drag it. And now after that on mid plates, edges here. It's outside, so make it inside. And now this one's edge with this one. Then after that one, you'll do the same for the right side. It's outside, make it inside. This one with this one. Done for the base and the mid plates. Now we will fix the screw inside here. So what you have to do is mate, and before you mate you have to make the screw rod. So move component, rotate, you have to rotate the screw that way so that it is modeled it that way. So now rod and this surface done, rod and this surface done, and now this surface and this surface. So now it's inside, and now after that one you just have to make the arms. Control C, 1, 2, 3, 4 of them. So now edge with this one with this one, now this one with this one, and now this one with this one. So after that one you have to make these arms connect with the top plate. So we have to first meet this surface with this surface, this surface with this surface, this surface with this surface, and then finally this surface, sorry, this surface with this surface with this surface, and this surface with this surface. So that's with the mating part. And now you'll get them all like this. Now you have to make it fixed structurally. So you have to make it parallel, base plate, make it parallel with the top plate, and now it will become straight. And then we will assign angles. So angle this side and the bottom, and now you have to make it 55. So this angle 150. So like between these two it's just 25 degree, and now you have to do the same for the left side, this one and this one, sorry, this one, and now angle, and now you have to do this one and this one, and then angle you have to put it 155, and then you'll get it like this. So this is the completed image that you will be creating in SolidWorks. And now to import this in Abaqus, so first of all you have to save the file, Control S, and then you have to save it as a step ep214 step file, and now you can name it however you want. I will be naming it as 12 diameter. Okay, so now we will open the Abaqus, and then I will import this geometry into the Abaqus. Now I will be showing you guys how to import the SolidWorks file into the Abaqus module. So first, file, import path, and now here I will bring the path that I created. So I have two paths, like one is diameter 8 and diameter 12. So I will try to bring diameter 8, and here you should make it step 5. And then these are the paths. So first we'll assign the properties. Density is 7.85 used minus 0.09, and now elasticity 21000 0.3, and now plasticity, and we have 250, 0, 280, 0.002, 310, 0, 400, 0.03, 450, 0.08, 480, 0.15. So these are the material properties. Now I'll create a section. They all are of the same section, so you just have to assign it as section 1, and the part you can just make it section 1 and do like that for all the parts. And now after you have assigned section to each and every one of them, you'll create the assembly, and then you just make it dependent. And now the assembly has been created. Now I'll create the step. So this one must be on. This one, maximum number of implementation should be 1000, and 0.0001. This should be 8. This one is 0.05. And after that one, now we'll try to create interaction property. Tangential, frictionless, normal, hard contact, and I will assign it to the whole system as a general contact. And now we will create, firstly we'll create a datum between 2 points. Now select this one, select this one, select this one, and select this one, and select this one, and this one, select this one, and this one. And after that one, we'll create reference points at here, 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 and we'll do the same for the parts. So first we'll do coupling. So you will, this reference point couple with this surface, this surface, and this surface, and this surface. Done. Now this surface with this surface. So that is the first one. And you can see like this, and now you will be doing the same for the bottom one and for these two right parts. So now after you have completed coupling the pin joints, they will look like this. So you need here the outside surface, the inside surface, the outside surface, the inside surface, the two outside surface, and the inside surface, and you have to do like that for every one of them. So at the end there should be a total of 20 coupling at the bend joints, and after that one let's try to create, okay, here, and then here, here. Okay, so let's select this part, this part, this part, and this part. So we'll go to parts. Now we'll make partition here. So those, first we'll make a data, press plane in y-z axis, and then you can just paste them, and then so 4 partitions. Now we will partition using the datum plane. Mm, this one, create partition. Okay, so done creating partition. Now we will name the surface. First, left screw surface, and this will be this one, and the other surface will be right screw surface, and it will be this one. And then now we'll also look at the mid plates, and then we'll create here surface plate 1 surface, and then plate 2 surface. And then after that one we'll keep one reference plate at the top plate, yeah, and I think that's all. So after that one we will again couple, then okay, before we have to create one diagonal string. So surface will select this mid plate surface, and the sleeve surface will choose as the right screw surface. And then now we will create one reference point. I think we just create one reference point here, and let's also create one datum from here to here, and give a reference point here, and I'll create one and we'll give one reference point here. So first what I will do is I will couple this reference point at the center with the mid plate screw slot surface, and then we will need them, and then again we will couple this reference point with the screw rod surface. We don't need them. So done with this too. Now after that one, what we have to do is we have to assign hinges and all hinges and axle. So first hinges. Hinge, and we don't have to add anything here. And let's also create axle rotation on axle. So we so our right side is tie constraint, so left side here should be motion allowed. So we'll create one hinge between these two. We'll create one hinge between this one and this one. Not hinge but axle connection, and we will use global axis, and now we will create hinges between this one and this one. It should be hinges, and now we will have to create a datum axis, because for hinges rotation is only about UR1. So let's create a datum hinge local axis, and then select a point. Let's select this one, and then this one, and this one. So we have z-axis upwards, we have x-axis in this direction, and y-axis over there. So I think rotation will work. So we have to now choose hinge local axis. Done. And now for every single point you can use same. This one, specify and hinge local axis. Just OK, repeat. Now go to here, repeat, here, repeat, here, repeat, and here, repeat. Now we'll go to the bottom, base plate, here and here, repeat, here, repeat, and here, no, sorry, here and here, repeat, here and here. Okay, done. So we have created 10 hinges and one axle connection between the screw rod and the screw slot here. So now I think that's it for the interaction. Okay, now I will be applying boundary conditions. So before I apply that one, surface and this surface. Left screw motion. It is to mimic the screw mechanism. And now for the right side, you have to do the same. So datum between 2 points. This one and the other point should be getting this one, and then this one, and this one. Right screw motion. This is where we'll be applying our boundary conditions. And after this one, we also have chocolate coupling. This one, and then the top surface. I think that's all. And now after this, we will be applying the boundary conditions. So let's start with fixed base at initial, and then set, and then we're going to completely fix it. And now at step 1 we will adding left screw motion. So we'll add our reference point over here, and then we are going to add 40 and rotation about the z-axis. Let's make it 0, and we'll do the same for the right side, right screw motion. And then -40 and this one, and after that one we will be adding boundary conditions at the top plate at initial to make sure that the top plate doesn't tilt in left direction or right direction, so that it stays fixed. So this one, U1, we will log the rotation about x-axis and then also about z-axis, so it will only be able to move up and down. And now after that one, we will have to mesh the parts. So before we mesh it, we have to create 2 steps. One step is for the screw motion to lift the jack, and the other step is for the load to be applied at the top plate once the screw has been lifted. So for this one we will use static risk, and then over here we will make sure they are on, and then maximum load proportionality factor 1, maximum displacement, let's keep it 3, degree of freedom 2, and node region, it should be MS36, I think. Let me confirm it once more. Yes, MS36. So after that one, we will change the settings a bit. We will add maximum number of implementation 1000, initial 0.01, this one 7, and this one let's make it 0.05. That's all. And now after that one, we have to change the boundary conditions a bit. So for the fixed space, we don't have to change anything. For the left screw motion, here we have to make everything 0 and just make sure UR1 is set free. And same for the right side. Lock everything, make sure only UR1 is free. And then for the top plate, we have to make changes a bit. And now for the top plate, we just have to add a bit in step 2. We have to make sure there's no rotation anywhere. So all of this is 0. So these are the conditions I will be using for my Abaqus project. These are the boundary conditions. And now for step 2, I need to add a load on the top plate. So load displacement, and then at this reference point, so let's keep it minus 0.2, and then it'll be only at step 2. So that's all for the load. And now for meshing, we have to go to parts, and each part, firstly we make it 10, so it's done. And then element type, we make sure it is C3D10, and then mesh size is 15, and for all of them, the mesh size, we have to do the same step. First make it here 10, and assign, make sure the element type is C3D10. Then after that one, we have assigned the mesh size of 15. If we use a bit lower than that one, the node exceeds our Abaqus limit. And then 15. And for screw, we just do the same. Then element type, we make sure it's C3D10. And for screw, we use it here 12. For the arms, we use 12. And then we have to do like that for almost all of them, except now for the screw rod. That element type C3D10. Okay, now except for this one, we use mesh size 18. And for the rest, they are all the same. So once you have assigned mesh to every one of them, you'll get it like this. This is how it would look. Then after that one, you just have to submit the analysis. And now after that one, once it has been completed, you just observe the results. So this is the result. So firstly, it goes up because of inward displacement of the plates that push the jack up to minus 40 and 40 millimeters of displacement on both sides. Then here, step 2, you apply low displacement on the top and it starts to react, and then it starts to deform. So this is how it looks after it has been deformed. And now if you want to get the graphs, you just have to ODB field output and then reaction force 2, and then here node set, here top plate reference point. So you have to make sure it's just step 2 and then plot this the RF versus arc, the force versus arc length, and then you just have to save it. Now for the second one as displacement, and this one, and you save this one as well. And now once both of them are saved, you just have to operate on XY, combine, and you do this one, comma, this one. You make it positive here, so that's why I'm multiplying it with -1. And plot the expression. And this is the graph that I obtained for 8 millimeter diameter of pin joint. So this is how you obtain the result, and that is how you will be comparing them. But and then this is the peak, this is reaction force RF, and this is the displacement. So that's it for my project, and thank you for attending this video presentation.